Okay, we're going to look at rational, which means fraction, exponents. Maybe never thought of exponents being fractions before, but it can happen, and we look at it because it has to do with roots. So here's some things to motivate the idea. Think about this. If I want something inside these parentheses that when I square it, I get x. Well, it makes sense that what should go inside here should be the square root of x, right? Because when you square a square root, the square root goes away and you just get x. Okay? So let's look at it another way. What else can I square and get x? Well, if you think about it as x to some power, right? X to some power that we don't know, how would you combine these? Well, you would multiply the two exponents, right? And so the question is, what do you have to multiply by 2 to get the exponent of 1 on the right hand side? So you'd multiply these two exponents to get the 1 that's on the right hand side. Well, the answer is, what would you multiply to get 1? The answer is the question mark would have to be 1/2, because 1/2 times 2 is 1. So what I'm saying is, you could write the square root of x squared equals x, or you could write x to the 1/2 power squared equals x. Okay, and that's true, right? Because if you multiply 1/2 times 2, you get 1, which is the exponent on the right hand side. And in the first case, when you square the square root up here, you get x as well. So what does that mean for us? That means that the square root of x is the exact same thing as x to the 1/2. So we've already understood some sort of rational or fractional exponent. Okay, let's try another example here real quick. What if you want to raise something to the third power to get x? Well, a natural way to do that might be to use the cube root of x. When you cube a cube root, it goes away and you could just get x. Similarly, what else could you cube to get x? Well, you could cube x to the 1/3 power, because when you multiply 1/3 by 3, you get the exponent of 1 on the right hand side again. So again, what that means for us is the cube root of x equals x to the 1/3. So in general, x to the 1 over n, this is a fraction now as an exponent, means the nth root of x. Okay? And so what I want you to take away from this is, when you have a denominator and an exponent, that is a root. It's your index on the radical. It's your root. Okay? So let's take this even further. What if you have, what is the meaning of something like this? X to the 1/2 to the third power. Well, you could look at it in two different ways. One way would be the square root, because 1/2 would be a square root, the square root of x quantity cubed. Or another way would be, if you were to multiply the exponents again, you would get x, and when you multiply 1/2 times 3, you get 3/2. So what that means is there's two different ways to represent this, and they're both equal to each other. Okay? So now let's examine this. Over here you have a square root. Well, that makes sense over here because 2 is the denominator and that should be your root. So you do have a square root. Now the part we're going to learn is the numerator in the exponent should be the power in the expression. So in general, if you have x to the m over n, now your numerator is not 1. That means your root is n, so you've got the nth root of x, right? That's your base. And that whole thing is raised to the power of m, because m is your power, or your exponent. So your denominator is your root, your top is your power, or exponent. Let's try some examples. So in all of these, our root is 2 and our power is 3. So I've written them all as square roots cubed. And the only difference between the last two is this negative goes outside and this negative goes inside, which means this last one is not real. The first one's 8, the second one's -8.